So we just mentioned that for a single point on the plane, you can use lots of polar coordinates to describe it. There's that r and s, which are both at that same spot, 2 negative 5 pi over 6 or 2 7 pi over 6. But there's only one xy value. So this is the nice, easy way of translating. If you know the r and the theta, you can get the x and the y using these formulas. X is equal to r cosine theta, and y is equal to r sine theta. That's from the picture above, where you can see it as a right triangle, and the r is the hypotenuse, and then x is always going to be adjacent to the theta, and y is always going to be opposite from the theta. So you can use those coordinates even when the angle can't be used to draw the picture of a triangle because it's bigger than 90 degrees, go all the way around, but the formulas still work. So for an example, we had above the point that was given by r equals 3 and 7 pi over 4 was the angle. So x is going to be equal to 3 cosine 7 pi over 4, so 3 times square root of 2 over 2, and y is equal to 3 sine 7 pi over 4, so 3 times negative square root of 2 over 2. So there's the that point Q is, well, that was P. And then we found Q. You have to look back at the picture to see them. And that's negative square root of 3 over 2 times 3, or and positive 3 times square root of 2 over 2 for the y value. So let me just look back quick and see that that makes sense. Yeah, Q is at a negative x and a positive y, whereas P is at a positive x and a negative y. There's that one and that one. And then R and S both have exactly the same one, exactly the same value. It's hard to read that, but it's negative 2 times the square root of 3 over 2, and 2 times 1/2, so comes out to negative square root of 3 and 1, and you get that no matter which point values you use for R or S. Here's a couple more equations that are going to be useful for going the other direction. First of all, there's the equation for Pythagorean theorem, that r squared is equal to x squared plus y squared. That will always be true for any point, because you can always use sine and cosine for x and y. And then there's tangent. So tangent is opposite over adjacent. That'll be y over x. And similarly, you can use sine or cosine solved for sine or cosine from the previous. Like we said, y was equal to r sine theta, so sine theta equals y over r. So then the question is, if you're given an xy value, find r and theta. And they won't be unique, but you might want to find them for purposes. And so here's how you do it. First of all, you should graph the x and the y, because you want to know where that point is going to be located so that you can make sure that it actually makes sense when you find r and theta. Then you can find r using the equations and theta using the equations, and you make sure that it fits the graph. So here's what I mean by that. Here's an xy. Negative 4 times the square root of 3 and positive 4. So that's about negative 6.93 and 4 on the y-axis. So it's that point that's drawn there. So I put a line through it just so that I could kind of see the angle and the radius. You don't need to do that. It's just the point that's important. And here's the actual calculation. I didn't know precisely what this angle is going to be yet. Here's how we found it. We said first r squared, and that's going to be equal to x squared plus y squared. So it's 16 times 3 plus 16, which gives you 64. So r is equal to 8, just taking the square root of both sides. This will always give you a positive radius, so the method that I'm doing here will always give a positive radius. You could alternately make it a negative radius, but then you'd have to do the angle 180 degrees away. So I'll choose r greater than or equal to 0. Then sine of that angle, once I know r is 8, sine is equal to y over r, so sine is equal to 1/2. Now that doesn't narrow it down enough. In fact, if you use the inverse sine button on your calculator, you'll get the wrong answer. Because if you hit arc sine on calculator, you'll get pi over 6. But from the picture, I can see that it's 5 pi over 6, because there's two angles that give you sine equal to 1/2 in between 0 and 360. 5 pi over 6 and pi over 6. And from the picture, I know which one it is. It's 5 pi over 6. All right, next we'll plot some curves.